Hello, everyone, and welcome to this latest webinar from Omdia. Today's topic is recipes to a sustainable AI data center. Our webinar is co-sponsored by Omdia and our partner, Legrand. My name is Vladimir Galabov. I'm the director of the Cloud and Data Center Research Practice at Omdia, and I truly thank everyone for joining us. So before we get started, I wanted to cover a few housekeeping items. At the bottom of your audience console, there are multiple application widgets that you can use. Make sure you check these out during the webinar. If you have any questions, for example, you can submit them through the Q&A widget, which is located to the left side of your screen. All questions will be captured. So if we don't get to answer yours, we may follow up via email. An on-demand version of this webinar will be available in approximately 24 hours and can be accessed using the same audience link that was sent to you earlier. Finally, if you have any technical difficulties, just click on the Help widget, where you can find answers to some common questions. This will be an interactive webinar, so we will be asking you some questions, and you will, of course, have an option to answer them. One of the ways that you can answer them is to actually submit a note to us. And now let me introduce our speakers. I'm very excited to be joined by Rebecca Gilstrap. Rebecca is the Director of Strategy for the Data Power and Control Division at Legrand. We have with us Calvin Nicholson. Calvin is the Senior Director of Product Management for Raritan and Server Technology at the Data Power and Control Division at Legrand. He's, in essence, our rack PDU expert. And then we finally, last but not least, have John Berenbrock, who's the Director of Product Management for Starline in the Data Power and Control Division at Legrand. Starline, for those of you who might accidentally not be aware, is the busway market leader. So thank you everyone for joining us. Welcome. Thank you for taking the time to do this panel with us. And what we'll do is we'll jump straight into it. I want to maximize the time that you get to hear from Rebecca, Calvin, and John. So first, I just wanted to give you a little bit of context and also explain why we went with this title for the webinar. Because I understand that, sometimes talking about sustainability and AI in the same context might not make sense. The reason why is that today, what we are seeing is demand for AI infrastructure is strong, but one of the big constraints is power availability. So the pursuit of efficiency, of making data center more sustainable, actually is a key unlocker of AI. So let's take a look at a few data points that will kind of exemplify that, and I'll walk you through a bit of a journey that your average tech company that is trying to invest in this is going through before we open up the floor to you. So what we've seen when we looked at the data center power capacity that is currently in deployment and how it's evolved over the last couple of years and where it's going, what we saw is that as AI deployments accelerated in 2023, we saw big growth in the demand for power. Something similar is happening in 2024. And in fact, when we look at the demand profile, what we see is that AI deployments will drive a 2 times growth in data center power capacity in the next 5 years. And I think it's important to bear in mind that some of the growth that we're seeing currently in 24 and in 25 doesn't take into account the fact that most enterprises are still in their early stages of their journey of developing their AI strategy, especially their generative AI strategy. So as the long tail of enterprises that are small and medium ends up coming up with that strategy, what we end up seeing is AI deployments, the AI capacity within the data center becomes 45%. Now, this sounds like a lot. How do we suddenly double the power supply to the data center? The reality is that is very difficult. And this is why this chart shows you the IT load capacity. In essence, for us to be able to unlock the IT load capacity, there are four enabling factors. We could end up figuring out how to consolidate some of our other IT. We could potentially improve some of our utilization. We could pursue further efficiencies, or we could try to get our own power sources. But in reality, some of these have a longer lead time. They take more time than others. And as I was reading the news today, I saw that um, uh, the Singapore government ended up releasing a very interesting white paper where they themselves realized that to be able to unlock the power of AI within Singapore, one of the things that they will have to do is pursue improvements in data center efficiency. They will have to find the power savings. And probably the area that their guidance aligned the closest to was this third area, the further efficiencies in PUE, and the second area of IT utilization improvements. We will talk about both of these today. But first, I want to talk to also kind of highlight the fine balance that a data center operator is going through. And in essence, this is not just a data center operator, it's any ambitious AI tech company. If Calvin and Rebecca and I tomorrow were decided to kind of create an AI tech company, we'd end up having the same challenges. Hopefully, John will stay at Legrand so that he can help us. But bottom line, there ends up being we'll be exposed to exactly the same conditions. So the goal for this ambitious AI tech company is to be the first to develop a popular, commercially successful AI app. To do that, you end up having two constraints. On one hand, it's the cash constraint. An AI optimized server is very costly to have. There are, of course, by the way, many other constraints. I'm not saying these are the only two. Availability of people is one, but cash is kind of fundamental. It's a fundamental constraint because it's very costly. Some of the capex that we saw in terms of increases from Google, Microsoft, Meta, this year is increasing their data center capex by a third to be able to fund this. So the money is a lot. But say that that's one problem. All the money in the world today cannot buy you enough power, and AI optimized servers consume a lot of power. So these are the two constraints that you're going to inevitably be exposed to, amongst many others. But these are kind of the hardest to crack and the fundamental constraints. The first one is a little bit easier to crack because if you have enough money today, what you can do is instead of building your own AI infrastructure, you can rely on a partner who already has that, and you can end up using it. And this is happening a lot. Microsoft currently is relying on Oracle because Oracle has already deployed some AI clusters and Microsoft is using them as a service. So that's one kind of quick solution. You could, however, decide to build your own data center because you want to keep your competitive advantage in your company rather than end up funding Oracle's expansion and profits. In that case, you need to ask the grid for power. Now, if the place where your data center is located has enough power, there will still be a lead time. So there is a 4 to 6 month lead time for getting more power from the grid. Since our goal is to be the first to develop a popular commercially successful AI application, if we have to wait for 4 to 6 months, that means that we're exposing ourselves to risk. So say that we cannot wait for the grid. There is one thing that we can do. We can find a power saving in our existing data center to be able to start deploying AI today instead of waiting 4 to 6 months for the grid. Of course, we can still rely on a partner. We can also build a new data center to run AI somewhere else. Unfortunately, this doesn't necessarily solve the lead time problem because building a data center also takes quite a bit of time. Or we can, of course, choose to get our own power source. We can say, the grid cannot, I can't wait enough, so I'll build my own power source. This is particularly a solution if there is no ability to get more power from the grid. In many locations today, Singapore, Dublin, Amsterdam. I can keep going. There is just not enough power. So as a result, this idea of building your own power source ends up being a solution. Of course, if you're unable to get more power from the grid, the same solutions as the solutions that enable you to not wait end up helping. The challenge with installing your own power source is that it takes time. There's a lead time. And the higher the power generation of your own power source is, the longer the lead time. So it's an extra problem. So you could end up just waiting and or not doing it. The problem is that then you end up missing the opportunity to develop the killer app and potentially, kind of make loads of money. You could, if you only rely on partners, what you end up doing is you fund another company's growth. So you end up impacting your own capex to invest your own kind of competitive advantage build out, and instead you fund someone else. And this actually is the case if you decide to build a new data center. Just building a new data center consumes capex, which you could have spent for AI. And then, of course, if you decide to build a new data center and that's your only strategy, matching where power is available might not necessarily match where end users want to have their data stored. And that is, or where they prefer to have their data stored, or even where regulations are. And I'll give you an example. One of the crypto mining epicenters of the world today is in Kazakhstan, but I'm not sure that our potential clients would want Calvin, Rebecca, and I to expose their data to being stored in a country that has very different regulations from what the US or the EU has. So that is a problem. And if you end up then kind of going into this back and forth, again, you can end up missing the opportunity. But there is some low-hanging fruit that you can end up using. So one thing you can do is improve your PUE. So that is the effectiveness in how much power you waste during distribution, how much power is consumed by your power distribution systems, and then, of course, how much power is consumed by your cooling equipment. That is one very effective strategy, because potentially you can deploy stuff that deploy strategies that don't have a starting cost. So it could be very interesting. In essence, just changing your operations can end up helping you with PUE. That was one of the central debates within the Singapore government paper that was released today. A very helpful strategy could be to just switch off unused servers. Every data center has some unused servers. And switching those unused servers, you end up losing nothing, but actually gaining power. Typically, a server that is 0% utilized still consumes 50% power. So as a result, you end up wasting power for nothing. Then you can just stop. And then finally, you could consolidate your servers. If you consolidate your servers, you can do it in one simple way where you just change your utilization targets, you change your practices. If you monitor your utilization, you can end up making a decision that it's worth changing, or you can buy new servers. Unfortunately, the problem with buying new servers, these servers are costly, so then you end up impacting your capex for AI infrastructure. So it's not the perfect strategy. And these black squares are, in essence, the low-hanging fruit, the lowest possible investment for the highest possible gain when you compare it, and stuff that you can even do today within your data center. And that's why we decided to focus the webinar on this, because in reality, then you're able to improve your sustainability credentials. And then for each carbon ton of carbon that you end up emit, you might be able to do more compute by deploying AI. So the reason this matters is that power generation capacity is going to continue to grow slower. This isn't a problem today. This is a problem that will remain. At the moment, the power generation growth is about single digit, and the demand for the data center is growing in high double digit. On top of that, we're about to bring up another billion people to have access to electricity in the next 10 years, actually the next 6 years at this point, and we're about to see 6 times more electric vehicles. And in general, every aspect of our technology usage as end users, we're consuming more and more power. Our TVs are getting bigger. Our phones are consuming more energy. Everything in our life is requiring more energy. And at the moment, the grid is not able to generate that. So in essence, we think that we need to make, at the moment, sustainable practices are a AI enabler, but they're also a business enabler. So we need to recognize that power shortages are becoming the norm already, and that what that's doing is it's increasing the importance on finding power savings, finding efficiencies, being smarter about how we use the infrastructure within our data center, being smart about how you use your PDU, how you use your cooling system, how you use your what system you use to distribute power. And in essence, what's going to happen is we're also going to see regulation. I think that the Singapore regulation is looming, and that's why we ended up seeing that paper be released this morning. But in Germany, there already is regulation that limits PUE to 1.2 from 2027. In Shanghai, there already is regulation that limits PUE to 1.3. So data center operators have to deploy a multi-lever strategy. And that's really what we're going to talk about today. We're going to talk about a strategy that ends up kind of utilizing every aspect that you can within your infrastructure to try to be more sustainable, to save more power, and that power, that efficiency can then be redeployed for you to gain a competitive advantage by developing AI within the same envelope. So I thought that in preparing for this, one of the things that we did is we actually studied what Legrand has done in-house, and then we also tried to study what is the different products, what is the different technologies in the data center that are used today from an infrastructure perspective that you can use for this multi-level strategy. So to give you a bit of context, I'll pass you on to Rebecca, and then what we'll do is we'll open up afterwards the floor to you, because we want to hear from you. And I just want to remind you before I pass you on to Rebecca that you can send us a Q&A throughout the webinar. Don't wait just until the end, because I'm going to be scanning for your questions. With that, Rebecca, the floor is yours.
Thank you, Vlad. I appreciate that. So again, it's a pleasure to be here, and we appreciate the work that you have done, Vlad, to share this data with us, and then also, asking us to do a case study on the sustainability efforts that we have in place. So the biggest thing for us is that we look at sustainability in kind of three core spheres of influence. And the first one is how we are as a company and the culture and what we do to set initiatives that can represent, our beliefs, again, as a company, and how we can impact the environment. So then what we do is, taking those CSRs, we implement pieces into our product design principles. And so looking at eco-design and even packaging, right? How are our products going out the door? How are they getting produced? Who is producing them, right? What materials are we using? And then we take it and look at it as those products are going out into the environment, and more specifically going out into the data center environment. And so there's multiple layers in how our products impact data center operators and owners, and even the actual operation of the data center. So it's the products that are chosen, it's how they are designed and manufactured, and then it's how they also interact with the environment that they are in, so that we can drive that efficiency and, as you said, Vlad, that CapEx savings. So that's built into a whole host of our different products. And just in case anybody isn't familiar with Legrand or with our products, we do have a whole host of different specialized white space products. Everything from, as you can see, our overhead, our market leading overhead busway, cabinets and containment, rear heat exchange doors, again, market leading intelligent rack PDUs, and everything from connectivity to fiber, copper, transceivers. And then also we have remote access products. So from our KVMs to our most recent acquisition of ZPE, and a lot of the devices that they have to get out-of-band management that are being used in core data center white spaces that are driving productivity, they're driving security, And again, we have sustainability built, throughout the product categories as itself, but also how these products are interacting with the data center environment. And this is a great picture to show you all of those pulled together in a data center pod.
That's great, and I think one of the reasons why what I think what why this is important is that first, you can, as you listeners, you can ask Rebecca, Calvin, and John topics on both power distribution above the rack, inside the rack, cabinets, airflow, cooling. We can go into any aspect of the data center. So you can challenge them as we go through this. And in general, our topics as we kind of now kick off the Q&A will include all aspects of these technologies and these technology areas, because for a data center operator, it's not a singular decision that they need to make.
Yeah. And Vlad, I'll just add on, to that sentiment, which is each of these products can stand on their own in terms of their impact to the data center. But as you just said, when you actually take all of them in combination, there is a lot of impact that can be put into that data center operations. And so again, I'm more than happy to dive into any individual product category, or to talk about it holistically in terms of design and implementation.
Excellent. And by the way, I can see questions coming in. Thank you so much for sending them. We will absolutely get to them. So before we get into questions to the panelists, I wanted to open the floor to you, our listeners. So I'd like to hear from you, what are the biggest roadblocks to improving data center efficiency and sustainability that you have faced? Now, here you can choose 3. Please note that you can also scroll to the bottom. You don't have to stay at the very top of this chart. And, here I've put some common challenges, common roadblocks to improving data center sustainability. I'm curious to hear what are yours. If you can please select up to 3 and click submit. I'm going to monitor your response, and then in a few minutes, I'm going to show you the results. So one roadblock that we've heard of is data availability. This can include lack of standardized criteria and solutions for measuring the impact of sustainability programs. We've also heard that there is a cost to implementing sustainable practices. And this can include challenges in making a strong business case and lack of knowledge about business benefits. And we also hear that regulation can be difficult to stay compliant with, to stay up to date with. So that's one of the reasons why we've listed it. We know that there's a wide variety of IT equipment, and that this can sometimes create a challenge for data center operators because you might have different rack densities, different clients of your own. So that's why we've listed this. Availability of renewable energy is frequently quoted as a roadblock, so that's why we've listed it. We're curious if that is the case for you. Lack of standardized best practices is another one. Understanding which technologies can have the biggest impact. Data center efficiency being determined at the design stage is something that I heard consistently over the last few months, saying that once you've designed it, you cannot improve efficiency. I'm going to ask in a second our panel if that is the case. Supply chain and partner-related carbon emissions, I know, can be a challenge. And then implementing circular economy practices, it takes a lot of work. So that's why we've listed it. And then finally, the ability to monitor power quality can be hard. So that's why I've listed it. But maybe let's start while we wait for you to answer, and I can see that the answers keep coming in. So I'll wait for a lull in answering before I stop the poll. But maybe I can hear quickly from the panel. Do you think that data center efficiency is only determined at the design stage and cannot be improved? I'm curious to just hear your perspective, because I've heard some very strong voices in the industry specifically about this as a roadblock. And I'm curious, maybe we can start with Rebecca. What do you think about that?
Oh, I mean, I think it would be sad if we were to say it's only at the design phase. I look at us as an industry and the continuous improvement that we are achieving and going after. Then, just from a Legrand perspective, you look at many of our products are part of the refresh cycles and where people look to in terms of getting more data and information on their environment and improving. Other products such as like containment are a perfect example of how many people are actually they'll build out and containment will not necessarily be a part of the design. Then they quickly realize, the benefits and the need for containment. So a lot of times containment's going in as a retrofit solution to help drive that efficiency, lower CapEx costs, and really take care of, hotspots and get the cold air where it needs to be. And that is part of, I think you'll be talking about it in a little bit, and we'll touch on it as, it's the heterogeneous, like you said, Vlad, the stair stepping into different systems so that you can grow and scale and have that flexibility. So again, I hope that those answers don't come in that we're capped at the design, because there's so many different ways that we can retrofit and, go in and be proactive about the environment past the design stage.
I agree. And so we have a lot of answers that have come in now. So I think what I'm going to do is I'm going to close the poll and we can take a look at what are the biggest roadblocks to improving data center efficiency and sustainability for our audience that is on the call. So data availability, tracking scope 1, 2, and 3 emissions is a challenge for nearly a third of the people. The biggest challenge is the cost to implement. So I think that, one of the things that I'll ask you, if that's all right, and I just want to give you a heads up, is it always really costly to be more efficient, to improve efficiency, to be more sustainable? And can you give us examples of some low cost strategies? Actually, why don't we start with that? And Calvin, maybe I'll go to you. To be more efficient, to improve the data center sustainability, do we always have to have a net new CapEx? Is there something that can be done without having to buy new equipment?
Well, it's interesting, Glenn. You had mentioned a couple of examples. Obviously, if you buy a new server, yes, it could have a more efficient power supply, but there's a ton of cost there. I see the data availability and the cost to implement kind of as a chicken or an egg, right? I often go back to the green grids mantra that, you really can't improve something that you're not monitoring or managing, right? So if there may be a cost initially in the design, but the monitoring pays off tenfold down the road for, the virtualization and consolidation stuff you've talked about, whether it's environmentals, to Rebecca's comment on the cooling and the effects that has. Maybe you can run your data center a little bit hotter, right? Which doesn't involve a lot of change other than you may want to monitor it a little bit closely. And, the data has shown that the servers really live just about as long because of the refresh rates, right? In most data centers, let's say 3 to 5 or 3 to 6 years. So, all the initial things that we need to do to improve efficiency, a lot of them do revolving around having that data. And in some cases, there may be a cost to implement. In some cases, there's not. But it's true that the monitoring is key if you tweak or make changes to understand how that affects the overall efficiency of your data center.
John, what's your perspective about kind of this balance of cost and then the challenge of data availability? So is it possible to improve data center availability kind of quickly? Are there any solutions to do that? And then I'm curious if we should consider those as super costly, or if there is a comparatively low cost way to improve data availability.
Yeah, I think I'd echo what Calvin said. Adding monitoring, it can be as costly or as inexpensive as you kind of want in the level of detail and granularity. So one of the nice things at Legrand is we can monitor, kind of at the row level, at the rack level, at the server level, between all of our systems. And one of the easiest ways that we look at it is, for efficiency is, our busways need to have balanced loads. So when the loads are balanced across all 3 phases, you're inherently more efficient. But if you're not monitoring that, and this is just one example, there's no way to ensure that you do have balanced loads. You have to go back to your upstream equipment and make sure. So, that's just one example that we can do. And again, down the chain, as far as you want to take it, we can help you grab that data.
I'm curious if so a third of the people of the attendees of the webinar have an issue with understanding which technologies can make the biggest impact. What advice do you have for them in terms of kind of understanding that? And is that important? Should we worry about looking at the biggest impact? Is a best strategy to start somewhere? Kind of how do you see this as this process of improving data center efficiency? And maybe we can start with Rebecca.
Yeah, absolutely. So one is, I think it's just like transparency. I mean, there is public data available, not just to the largest data centers out there, but just publicly available data from the DOE, which we partner with, on data center power usage and where those concentrations are. And so that's one place to start, and we can certainly share more information on that, Vlad, after the call. But starting there and looking at where are some of the averages and where and then focusing on those largest consumers and the majority of that, and you've covered this before, Vlad, in your research, is from that IT equipment. And so it's having that interaction with the IT equipment, supporting the IT equipment, the physical infrastructure that is tied to that IT equipment, and then the IT equipment itself, right? So how can you get a longer lifespan out of it? How can, as Calvin said, how can you run it hotter, right? How can you have a hotter environment? And then, again, how are you including in that refresh cycle as you extend it? How are you including more efficient technology as you pull in that refresh cycle and prioritizing those things, and then not measuring it just by cost, in terms of CapEx, but also looking at it from an operational perspective. And I think that that's something that, especially from a co-location perspective, it's been built into who we are as an industry. Looking at what is the ROI on the operations of the data center versus just that upfront CapEx cost. So you have to balance those two, your CapEx spend versus your OpEx savings.
It does feel like this is still a reference to what Calvin said earlier, that you cannot improve what you're not monitoring. Mm-hmm. So understanding how much different aspects of the data center are consuming from a kind of power perspective can help you to make the right decision. And in the question we had in the chat, we had a question about kind of server consolidation, and I'd like to actually slightly change one of the first questions that we were asking you as the panel. So we already discussed some of the biggest challenges, but I'm curious, from a server consolidation perspective, do you have any advice on how you, kind of what is a strategy to figure out how to do that? Because I feel like very often there is a perception that server consolidation means, go in and buy new servers. I think very rarely do we see a discussion of figuring out server utilization. And maybe Calvin, you can take that one, because I know that you have a perspective on it.
Yeah, absolutely, Ved. Well, I mean, first, obviously, you got to follow the money, and 40 to 60% roughly of the power in your data center used in the cabinet, right? And I saw a recent study, can't remember, I think it might have been Uptime or somebody. Anyway, only about half the organizations right now have the ability to monitor their server utilization. So it's hard to do utilization and then consolidation if you don't really have the data to understand how you move those workloads and how you can maximize efficiency. And you made a very solid point earlier that a server sitting idle uses about half its power doing nothing, right? Which kind of gets into an old topic that I don't really hear as much anymore, but I still believe is relevant, is the the old zombie server concept, right? Where there's a bunch of servers that get implemented, they have a use, there's they're not being used anymore, and they're sitting in the data center taking up power. And if you'll monitor those servers, you can see that the loads are not changing, right? They're not being used. You can profile them and understand what the load is. And then when you see the load not change, then it's very easy to understand that maybe that's a server you want to take out of service versus just disconnecting the network connection and then kind of waiting for an angry phone call. So there are some proactive things you can do. I think maybe companies have gotten a little spoiled. There's been plenty of available power. I think some of the server consolidation and virtualizations efforts have yielded good results, and they've went on to do other things or different battles, right? So I think this shortage of power that we're seeing in this kind of AI space race that you mentioned earlier, which is an unbelievable investment up front. So a ton of panic and urgency on the back end to start utilizing these GPUs is going to drive a lot of behavior that we've seen in the past. Maybe it's been overlooked a little bit, but again, like you said, you're going to have to do that if you're going to have the overhead or the capacity to install some of these new systems that are much more KW intensive. We're seeing a lot of standard products. We're kind of in that 17 KW. Now we're seeing a huge uptick in 400 volt, 60 amp products that are 34, 35 KW right out of the gate. So that amount of power and the demand for products we're seeing that deliver a lot more power has radically increased last year and the beginning of this year.
I'm curious, John, from your perspective, what do you hear from clients, right? So are there any consistently overlooked areas when you talk to them and, when you kind of hear about efforts to improve data center efficiency?
Yeah, I think one of the biggest things, and maybe I'll take it in a slightly different direction. Calvin mentioned that, we went from 17 to 34 kW in at about a year. And I think that one of the things that we don't know is where we are going. So when you think about sustainability, I look at it in terms of flexibility. Like how are we going to scale next year when it changes from 34 to 60, to 100? And so when you're choosing technologies that are sustainable, you want what's more sustainable than a technology that can be flexible and grow with you and scale with you. So I think, that's an overlooked area. And how we approach sustainability, in the way we move about those conversations. So I think that is overlooked.
I agree. In fact, so Rebecca and I have been working on a kind of summary of potentially all of the areas that people can end up kind of deploying. It ended up taking us quite a bit of time, but one of the things that we saw is that this idea of reusing, of being able to have something that you can have for the longest possible time, it's really a key part of the circularity. And I think very often when we think of circular principles in the data center, we think of very simple recycling processes. We think of, reusing bits and bobs of the IT, but actually very rarely do we think of how you can use the technology at the design phase that just has a long use life because it's flexible and you can redeploy it and it can grow with you and you can end up just not having to replace it so that you don't have something new doesn't need to get produced for you. And yes, that's a very good point. So I think what I'm going to do is reach back to the audience, and I just want to focus our discussion a little bit more on a specific topic, and that is power distribution infrastructure. Why? Because power distribution infrastructure is one of the aspects that end up impacting PUE, right? It's one of the things that end up impacting your efficiency. So which of the below do you think can have the biggest impact on increasing efficiency within the data center power distribution infrastructure? Do you think that gathering and analyzing data at the server or outlet level can be helpful in improving efficiency of the data center? Do you think that gathering and analyzing data at the rack level is a better strategy? Do you think that gathering and analyzing data at the IT room level can help? Do you think that reducing power loss during distribution is a potential best practice? Is it prolonging the useful life of power distribution infrastructure, exactly as John indicated recently? Is it about distributing power to IT devices at 400, 415 volts? Or is there something else that we have missed out? And if there is something else, please use the Q&A box to submit what you think is what we've missed. But we would really like to know if there is a power distribution infrastructure aspect that can help you significantly improve your efficiency in the data center. And I already see one response from the other that I might as well kind of read out, and it's minimizing power consumption. And I agree, minimizing power consumption is very important, especially at the IT level. That goes back to this idea that Calvin had, that you cannot improve what you're not monitoring. So outlet level monitoring of IT utilization is very often overlooked. So to minimize your power consumption, you really do need to look at monitoring at the outlet level. And I can see that quite a few have answered. There's a few that haven't answered. I'm curious from the panel, is there something that you don't see here on the list of options that I'm giving the audience that you wish I had asked?
Vlad, I think that there's a piece in here that maybe Calvin can jump on of just talking about harmonics and, some of the monitoring that can happen around that, just understanding it, knowing it, and being able to do it at the PDU level.
I think that's very important. And Calvin, can I just say there is a question on harmonics in the chat as well. So as you do this, you'll also be answering one of the questions we have, which is how harmonics can be a factor that impacts efficiency. It lowers efficiency of data center. If you could touch up on that, that would be great.
Absolutely. First, I'll make one quick comment just on the outlet or the device monitoring, because we track, obviously, our product sales by groups and type of product. And the products that they monitor both at the in-feed and the outlet or the device level are by far our fastest growing and our highest selling products. And that's actually been a trend that's been going for a while. So I think people that are looking at that, they're not always utilizing it. But one of the things that is not often talked about in a data center is the fact that we've got a ton of switch mode power supplies. And we know that these switch mode power supplies generate harmonics. And that is seen in the data center in a number of different ways, right? It may be higher power supply failures within the servers. It may be inefficiencies in looking at the power factor, harmonic power factor. You can see how much power is actually being used on the devices and how much is being wasted. There's just data loss, heating, just a number of things that can happen. And right now, if you have a problem, it's very difficult to troubleshoot or diagnose it. You've got to get a meter, you've got to connect it up, you've got to take those samples. So, and then you got to analyze the data. So what would be better than a device that automatically monitors the harmonics within the PDU? And that's what we're doing on our next generation products that are out in the market right now. And so you can see the harmonics for current and voltage and power factor continuously 7x24, and understand if you have a problem, and then look at what you need to do to fix those issues and therefore, increase your efficiency. So we've seen it off and on for many, many years. We've seen very large new data centers where there's been problems. We've been asked to look at them, sent some multi-million-dollar analyzers, a few engineers. That's often the result. You've got harmonics that need to be resolved. And so we've built that into our standard product. So it's really a kind of a revolution or a mind shift. Also, based on certain events, we can do a screen capture and see the current and voltage on some of these events, if an overcurrent protector on a branch fails or some other things, and really get down to the nitty-gritty of what's going on and actually solve those problems, because overall it will greatly affect your data center efficiency.
Thank you. That's very helpful. And I'm going to close the poll in just 30 seconds. So this is your last chance to tell us what you think, and to also submit if you think there is something that we're missing from our options. We did get a very interesting question that I just want to quickly address myself. And it was, what should a co-location provider do where you don't have an impact on the IT, right? Where you can't increase the utilization of IT because it's not your decision. You're only providing the space. And I do think that, if one thing that you need to do is raise awareness, right? And even discuss IT utilization as a power coping strategy. Because in reality, I'm sure that at some point your clients that use your co-location space will ask you for more power as they're looking to deploy AI, for example. At that point, if there is power unavailable, I personally, as a co-location provider, will challenge them back, and I will tell them, let's start monitoring together your IT utilization. We can use, power monitoring, for example, at the outlet level, and then we can make some decisions together. In essence, try to become a partner, a advisor, a consultant to the end user. So because this is a problem for both of you, it might not be your decision how IT is utilized, but in the end of the day, it impacts you both. So with that, let's close the poll. We now have quite a lot of responses. Thank you so much for that. And the biggest challenge so more than half of the audience think that, and one of the impact in increasing the efficiency within the data center power distribution is gathering and analyzing data at the server or the outlet level. And just so that I can move us along, I will just ask Calvin to confirm. Calvin, if I was to use your rack PDU, could I gather data and analyze it at the outlet level?
Of course. And at the device level, again, that's where the bulk of the power is being used. What's interesting to me is the comment on the distributing power at 400 and 415, which is really what the rest of the world typically does. But in North America, we bring in 480 and we convert it all the way down to 120 volts. And so there's a lot of losses in those conversions, where if you distribute in the cabinet at 400 volts, you can use an auto transformer, and therefore you don't have the efficiency losses in the power conversion. Also, servers, if you look at the chart, you'll see that typically they run more efficient at higher voltages as well. So we have started to see more of a fundamental shift of 400 volt solutions instead of 200 volt to 208 volt solutions, both being three phase. But so there is some gains there, and based on scale, they can be significant, both in how more efficient your server will run, and then secondarily, like I said, in your distribution system of not taking 480 and bringing it all the way down to 120, which is essentially what 208 is, right? It's 120 volts out of phase that gets you your 208. So that was talked about a lot, kind of years ago, but it's still relevant today, that there are efficiency gains in distributing power at higher voltages within your data center.
So I want to focus on one specific aspect. So many of the respondents said that they think that reducing power loss during distribution can be effective, and that gathering and analyzing data at the rack level can be effective. So I'd actually like to focus on that. So John, I'm curious, to hear from you. So first, how can we reduce power loss during distribution? Can you maybe highlight one or two ways? And then can you maybe also, as a follow-up, kind of tell us a little bit about power monitoring at the rack level and how that can be done?
Yeah, thank you. I think that I'll focus on mechanical power loss maybe. So when you look at co-location providers, and thanks for the user to ask about minimizing power consumption there, but when you look at traditional power infrastructure, it might be, at the branch circuit level, might be a remote power panel with whips pulled under the floor. And traditionally, that's where the cooling, plenum space is. So when you look at designing a co-location, a new room or a new data center in general, it's I think important to look at how that cooling is provided and where it's coming from, and what topologies you use. So if you went to, for example, a slab on grade type of data center design, then you can put your power distribution overhead, keep your cooling focused on where you need to be with, say, like hot owl containment, right? And sort of Legrand's technologies, when you look at our portfolio, plays very well with that sort of slab on grade, very efficient cooling using, hot owl containment, for example. So that's probably where I'd look first. And so, for co-locations, let's start getting the power out from under the floors where the cooling is. And that's going to really make a big impact. Air dams are avoided. And in general, lots of downtime can be avoided because you're able to quickly adjust with what the end user is looking for. The second part of your question is at the rack level, how do we monitor that? So we take what we call our tap offs, which is the power distribution of the branch circuit off of the busways, and we can monitor at each individual outlet. So we can say, A run, B run, maybe there's multiple outlets on the tap off. We can take a look at each one of those and give you your, a revenue grade energy. So again, in a co-location perspective, where you may not know what the customer's equipment is, you may not know what their rack PDU is, we can go ahead and monitor that data at a rack level fairly easily with our technology.
And John, one of the questions that we have in the chat is, do materials influence the efficiencies of power distribution products? And I think this probably is, kind of works really well for someone who really is kind of at the big power distribution technology aspect. So is copper as opposed to aluminum improve operating efficiencies?
No, in fact, there's not much difference. The size of the conductors changes. So copper is obviously a much more efficient conductor of electricity. But what you do is you size conductor grade aluminum up, and it's about 66%. So they, in the end, have the same resistance, and that's what you're looking for. So that doesn't have a big impact material to material. But when you look at, say, cables to busway, then you can start to gain some efficiencies in that way. So cables, when you're laying multiple cables on top of each other, you have unknown impedances, unknown short circuit effects, and you have sort of a bigger space. And busway can start to provide some efficiency over cables when you look at, different topologies.
Thank you. That's very helpful. So we're going to move a little bit to thermal management. So if you could please tell us, which of the below do you think, as the audience, can have the biggest impact on data center thermal management? Is it addressing hotspots through a heterogeneous cooling strategies? Is it improving the airflow at the rack level? Do you think that improving the airflow at the room level will have better impact? Is it reducing heat generation from non-IT equipment? Has the big impact in improving thermal management efficiencies? What about eliminating water use? Is heat reuse programs a focus for you? Operating the data center at a higher temperature? Air containment solutions like hot out or cold out containment? And finally, if there's something else, please submit your note in the Q&A box. I'll leave you some time to answer. And in the meantime, I actually want to address one of the questions that we received in the Q&A, and that is, what is the best PUE that's been achieved using Legrand's technologies? And I'm actually going to answer for Legrand, because the thing is, I do think there is very frequently a big competition between data centers operators on PUE, and that's understandable. But one of the important things when it comes to understanding how PUE works is that it really does depend also on your location. Some of the best PUEs in the world can be achieved in climates where you can really use free cooling. And in reality, that's not possible everywhere. So this is kind of brings me back to the same report that I read from the Singapore government. There is a very clear realization there. Singapore PUE will never be as good as the PUE in the Nordics. And that is fine. So there, it's really more about finding an efficiency gain, improving the status quo. That should be the focus. So actually, in how you think about PUE, I would say that it's not just about thinking of what is the world's best PUE, but what is the optimal PUE that you can achieve, or how you can take steps to reduce your PUE. I think that's actually what's more important. With this,
Vlad,
I'll
just add on, I'll add on to that specific I agree with everything that you said. And specific to Legrand would be that we support some of the largest data center deployments in the world. And associated with them are some of the best published PUE. But that's not a single, like, I don't want to take that and say, oh, that's because of Legrand that's happening. And I think that we'll get into this a little bit, which is it is being conscientious of what you are choosing and how you are deploying, and having strong partners in that design, in that implementation, and in that ongoing operations of the facility, so that you can continue to have the POE at the design level, but then make sure that you're continuing to meet that and better that, through the operations and the lifespan of the data center.
Totally. And by the way, I'm going to show you the results now. Heterogeneous cooling strategies comes out as half of the people. And I should note that quite a few of the attendees also noted that liquid cooling strategy is something that they're looking at. And that's very fair. I think addressing the hotspots through a dedicated cooling strategy is a very good idea. I'm very glad to see that people understand that improving airflow can have a really big impact, because it's true. That's one of the reasons why most of the industry organizations do recommend the use of containment. And heat reuse program comes in quite high, which is also quite good. I just want to come back to the addressing the hotspots through a heterogeneous cooling strategy. Rebecca, can you maybe give us quickly an example of a heterogeneous cooling strategy that Legrand offers?
Absolutely. So at a very, very basic level, it's even just the cabinet selection that you are making and the airflow that goes through that cabinet. You can use blanks and dampeners, and there are all kinds of different accessories that you can put into that cabinet to make sure that the airflow is going where it needs. So it's one, optimize your airflow. That is also pertinent to containment. So what's your containment strategy? Again, making sure that you're taking that air, right, that is there, and maximizing it. Then you're going and you're looking at, okay, how are you producing that cool air that is in it? So the more efficient technologies to that, and getting that cold air directly where it needs to be. Because again, even if you have a mid to long-term plan to get to liquid cooling or direct-to-chip, specifically direct-to-chip cooling, you're still going to need, again, a heterogeneous solution to be able to tackle the other cooling needs of the data center, right? Beyond just that chip. So
Absolutely.
rear heat exchange doors and get you a nice stair-step function into getting that CDU in place, giving you the opportunity to build into that. And then off of the rear heat exchange doors, you can then, again, add in direct-to-chip liquid cooling as part of, again, a scalable, flexible, heterogeneous, mid to long-term cooling strategy, without doing a full-blown plunge of going straight to direct-to-chip. And again, going back to your CapEx discussion, Vlad, how can you build up a program, build up a plan to get yourself into that, while again not biting off too much.
I would encourage people to actually kind of spend some time just taking a look at what is possible with a rear door heat exchanger, because there is a bit of a misconception that I've seen in the industry that you can cool a few tens of kilowatts. Actually, some of at the top end, that technology is used for high performance computing, where you see 100 kilowatt racks. I think immersion cooling is a very interesting technology, but there's something very important. What I've seen with immersion cooling, and I comment because I see it in the chat, in the questions that are quickly coming in. Some of the things with immersion cooling that people forget is immersion cooling tends to be focused on cooling the entire system, every aspect of it. If you have a hotspot, for example, one chip is 1500 watts. Actually, the best strategy is to take liquid first to the hotspot within the tank. So it's, in essence, it's kind of like direct to chip within the immersion tank to cool it. That's what some of the vendors are suggesting now. So immersion cooling works, but in terms of being able to eliminate the power at the highest end, you need to even get creative with immersion. So one of the things that I encourage you to think as you think about immersion, because I can see multiple people are indicating we're going to go to immersion. Air-assisted direct-to-chip liquid cooling is being advised by OVH, for example, a cloud service provider and user of air-assisted liquid cooling, direct-to-chip liquid cooling, as being better. They're basically able to kind of right-size the number of fans they have in the servers, the number of fans in the rear door heat exchanger, and the direct-to-chip to be able to get to an optimal environment. So I would say don't go straight into a singular technology, explore different aspects, because otherwise you might end up just perhaps rushing into it, is what I would say when it comes to thermal management. So I want to, and we're at the top of the hour, and now let's give a homework to Rebecca, Calvin, and John. So I would ask you if you can tell them what expertise do you find most valuable in your data center infrastructure partner. Tell them what they need to work on, because in the end of the day, that's very important. So as you kind of tell us, what do you find most valuable in your data center infrastructure partner? I'm just going to answer one of the questions that is really easy to answer, and it's about the Singapore report. I've posted it on LinkedIn. So if you just find Vlad Galibov on LinkedIn, the last post that you see is the Singapore report. I've uploaded the entire report there. So you'll be able to see that. And then with this, I just want to give you guys, as the audience answers the last question, to give you some homework, maybe a couple of closing remarks. And I'll start with Calvin. Calvin, what do you want people to have as an action item, like a singular action item, as they leave this webinar?
You know, I guess it really depends on what your challenges are. You know, if you're in AI now and you're going into it heavily, then you can't avoid the cooling conversation. But of course, also you have to have the right amount of power, right? And I agree that certainly reference designs, consultancy, whatever you want to call it, you know, reach out to your vendors. At a high level, we can share what other people are doing, and we've got experience in how some of these systems are being powered. In many cases, it's a three-pronged power solution, and two of those supplies have to have 100% power 100% of the time, or you can lose efficiency in your AI. So we can help and understand and help you understand what other people have done to do that. So I think just reaching out to vendors and talking to them about what they're seeing and what they're doing to solve some of these problems is just a huge resource for the people out there.
And by the way, I still have received one extra question that we haven't answered. We will send you a note on it. I'll personally send it to the cabinet experts at Legrand to follow up with you. John, what would be the singular call to action that you leave our audience with?
Yeah, I would encourage everybody to take a look at their monitoring solutions. You know, what do they have in place and where their gaps are? You know, one of the things, and of course I agree with Calvin, you know, what have we done to help other customers as they race to implement their AI challenges? But you know, let's take it back to basics and let's look at your infrastructure. Let's look at your monitoring solutions. And I think, you know, we started the presentation saying you can't improve what you aren't monitoring. And I think that's what I would want everybody to take away.
And Rebecca, same question.
Yeah, I would just, I'm gonna turn it back around and challenge the audience and also the industry to really dig deep into, challenging ourselves and looking for these little treasures, right? These PUE treasure that we are chasing, and challenge yourself internally. So one of the things that Legrand did in our sustainability efforts is we actually partner with the DOE, and we did sustainability treasure hunts within our facilities to see where we could improve on energy efficiency and it came up with just really awesome internal finds. And so if you create that culture, it gives you the opportunity to solve these problems. And then it also, in having a culture where you have, supportive partners, we can help inspire some of those things. And we can also show you how you can maximize your functionality of what you may already have, and also plan for the future, again, as you're doing those refreshes, making sure that you're getting, the infrastructure in there that you need to scale, to be flexible, and that's gonna grow with you into those next stages.
Thank you, Rebecca. So with that, we're going to close off today's session. We will follow up with any unanswered questions. Thank you so much for joining us. And good luck on your mission to creating a sustainable AI data center. Thank you.